Hello, and welcome to the IWC 2020 virtual event. I'm Donnie Jackson, editor of IWC's Urgent Communications. Today, we're going to talk about high-power user equipment, or HPUE, which is about to become a commercial reality after years of anticipation. This is a topic that I've been very excited about for a long time. If you think back to 2015 and 2016, as the FirstNet procurement was being developed and implemented, officials for the FirstNet Authority and interested vendors repeatedly talk about how, quote, unique the nature of 700 megahertz band 14 was licensed to the FirstNet Authority. Now, don't get me wrong, getting access to 20 megahertz of nationwide 700 megahertz spectrum is pretty cool because those airwaves have terrific propagation characteristics. But by itself, the 20 megahertz of contiguous spectrum was not unique. I mean, after all, there's a 20 megahertz swath in band 13 right next door that's licensed to Verizon. But from a technical perspective, what really makes band 14 spectrum unique is that FCC rules allow it to support HPUE. And this high-powered user equipment lets signals from a device get back to a cell when they normally would not be able to reach it. In other words, it can greatly enhance the effective coverage of a network for the user. And this is important because coverage is incredibly key to first responders. Without it, they tell me all the time, LTE devices are a little more than an expensive paperweight if you don't have coverage. And it's a reality that's supported by multiple surveys and a ton of very compelling anecdotal evidence. I hear from everyone from the engineers to salespeople to vendors and government officials. So to give you a lot more detail about HPUE, how it works, and some of the different scenarios where it can benefit the users, we have an outstanding panel with 3 experts. If you guys could raise your hand as I call your name. Travis Hull of the FirstNet Authority, Bob LaRose of Assured Wireless, and Larry Greenstein of AirGain. All right. And I do want to say one thing. This is new technology, and so there are going to be certain things these 3 gentlemen are not going to be able to talk about, but I think you're going to get a lot out of the things they can say. So with that, let's get it started. Travis, take it away.
Awesome. Thanks, Don. Let me get my share going here. And I think you guys should be able to see it. So again, hi everybody. My name is Travis Hull, part of the FirstNet Authority. And I'm part of the products team. I've been here for about a year and a half, joined the team in October of 2018. Within the products team, my main focus is in devices and applications. Prior to joining the authority, I was with a company that integrates payload systems, or actually develops and integrates payload systems to unmanned air vehicles. I was an engineering manager there, worked for systems for the Department of Homeland Security and Customs and Border Protection. But I'm very excited to be here as part of my volunteer job that I do on the weekends is with a search and rescue team. I'm a canine handler, and then also a diver with a dive unit. So with that, we'll jump into it. So again, thanks again for inviting us here today to present the HPUE. Pretty excited to talk about it. As Don mentioned, this is brand new technology that's starting to go through a controlled introduction. So we're going to be talking about really how the HPUE can really be going into the FirstNet ecosystem and how this device might be used by public safety today. Really understand that this device is really a success story about collaboration between many groups such as AT&T, FirstNet Authority, FCC, 3GPP, Assured Wireless, and AirGain to really put together a solution that really is going to benefit public safety today. If we look at the overall connectivity for public safety and knowing that they're operating in these really challenging operational environments, we can really see how these HPUE devices are really going to make a big difference on how they perform today. If we really kind of step back and consider how the uplink signal in today's user equipment is really the weak link for these devices and LTE connection, we understand how HPUE can really make a change in how those communications are. And we'll look at some kind of visualizations of that here momentarily. And for multiple reasons, that uplink really is limited, which in turns really limits the connectivity and range, as Don mentioned, for the user equipment that public safety is using today. And it also, in turn, limits the overall throughput to it. This additional power through the HPUE really helps to balance out the uplink and downlink connections and provide that greater range and throughput that we're hoping to see, as public safety needs it today. To support public safety, the FCC authorized transmission on band 14 to a maximum of 3 watts to maximize that range and coverage. And then part of the reasoning for that was because public safety today uses these LMR devices that have the higher power and connectivity. The 3GPP Release 11 then defined the maximum output for these devices for the use of band 14, and is limited now to the max power of 1.25 watts to really avoid that adjacent channel interference. And this is really how the HPUE devices are really defined and how they're being utilized today in the field. So if we start looking at the overall benefits and challenges these HPUE devices, right? First, let's kind of take a quick look at the benefits to public safety. If we start thinking about wildland fire scenarios, we've got crews in the wild of areas that are either right on the edge of cellular connectivity or completely in an area that they don't have the connection. This HPUE devices give them that additional range to provide that communication, data sharing, and image sharing across, through from where the teams are operating in the field back to base camp or whomever they need to communicate with, to get something as simple as and important as a map down to see where they're at, where their other assets are located, information like that to give them situational awareness. And if we think about also kind of the telemedicine today and how in these rural communities we're looking for ways to provide health information from either an ambulance that's en route or has received a patient is returning to the hospital, so that receiving patient care can be realized in a more effective range because they're getting that data sooner than if they would have to do a handoff from the ambulance itself to the receiving physician, or as it gets closer and closer to that receiving hospital. This gives them that additional range and ability to communicate through the distance that's really going to be unique through the HPUE device. If we then look at the overall network benefits, especially if you start thinking about some of those rural communities that have fewer cells, that in the past they wouldn't have the connectivity on a basic user equipment, and they would, in theory, need to put in more cell sites in order to create that connectivity. This HPUE can take advantage of that existing infrastructure of those fewer cell sites and reach out to them in order to get that data connectivity. And it allows them to optimize that resource allocation as the tower is communicating with the HPUE device in order to get these link budgets balanced to get the data and power up and down from these systems. And then finally, just a quick look at some of the challenges that we're looking at. Right now, the current solutions of the high power user equipment are mounted units to go inside of a vehicle, or in the case of Airgain, on the roof. That's because, of course, these have these higher power transmissions, so they're actually power connected devices. We want to take advantage of the native power within the vehicle to also produce the power within the HPUE to give it that additional range and ability to communicate. Part of that challenge too, when you're thinking about a handheld device and the specific absorption rate and how close that device can be to the user's head. Right now, these solutions are going to be vehicle mounting because of the additional power that these devices are transmitting. To kind of give a visualization to look at some of the range information that Donnie had mentioned in kind of the introduction here. I like this slide because it kind of gives you a visual on how your standard user equipment, in this case a phone, operating at that 0.2 or the 0.2 watts or 200 milliwatts, gives you the range and coverage that you're kind of used to today as a commercial UE equipment. Now, if you look to the right of that, you see the HPUE and how it's going to start giving the user that additional range and connectivity at the 1.25 watts of maximum power. to get you that additional coverage and communication capability, overall throughput that the people are hoping, that users are expecting and hoping to take advantage of today. Also, definitely worth noting, all the HPUE devices today really do operate on all bands. They're not just limited to these band 14 connectivity. When you're in areas where you might have a better connection on a different band, it will go to those and isn't dedicated only to go into that band 14 connection. So now as we start looking at the devices that we have today, we'll take a quick glance, kind of high level view as my co-presenters here are going to be going to you. You've got the Assured Wireless USB modem on the top right, and then below that you have the AirGain AC HPUE modem itself. You'll see that both of these have that FirstNet Ready badge. Well, what does that really mean? It's a unique identifier for FirstNet and the overall capability that shows that they can connect to the FirstNet system. It means that both support band 14, obviously. They accept the FirstNet SIM, have priority and preemption, and are capable of are compatible with the FirstNet Evolve packet core, which of course is really one of those differentiators that comes with being part of FirstNet. As of June of this year, both are on the National Institute of Standards and Technology, also known as NIST, list of certified devices. Any of the devices that are compatible with the FirstNet system are listed here. So going through the tests that allow these devices to be part of that on the list is a very significant milestone, because there are hundreds of tests covering aspects such as security, durability, and overall network compatibility that these devices have to go through in order to get this FirstNet Ready badging. We really anticipate that these devices are going to be a real differentiator for public safety and their use on FirstNet, because of this unique ability to transmit on the high power of band 14 and really work and transmit per these FCC requirements and 3GPP standards at the 1.25 watts. 6 times the power compared to your standard user equipment. Really looking forward to seeing how public safety will utilize these technologies in ways that we just have not seen before. And then finally, we kind of take a look at some of the use cases. I'd mentioned 2 of them earlier. Again, to touch on wildland fire and going into a realm that I'm kind of near and dear to my heart of unmanned air vehicles or drones. Teams are using drones more and more often in order to get a video visualization of where either hotspots are, where active fires are, or where their assets are today. So if you think that they want to be able to push that video, telemetry, other information out, both to the local team in the field, but also to the teams that are coordinating the event that may be over the much further distance or over the horizon from them. If you think about that additional ability to provide that uplink capability from the HPUE, we can stream that video real time through the HPUE device to get that information that both the local team needs and the incident commanders and the ones that are planning overall response can get that information real time, as opposed to hoping to get a snapshot from a phone that comes in later with another team, or maybe even a printout. This is real time or near real time actionable information that really becomes a game changer when you're doing incidents such as this in the wildland fire scenario. EMS we mentioned about, as well as telemedicine, how we get that additional range and capability to communicate in these rural environments that may not have that information and connectivity before. Again, search and rescue, something near and dear to my heart as a volunteer and regular responder. I'm up in the Pacific Northwest, and we respond 90% of the time in the woods. There just is not connectivity. So having something like an HPUE device that would allow my teams to communicate, know where they're at, where their assets are again, gives us, again, a real differentiator, especially when we find little Timmy in the woods, to getting the quick response of additional care and then getting him back to his family in a timely fashion. So building penetration too is something really unique once we start thinking about the urban jungle, right? We've got facilities that are deep in the concrete, such as once you get into these deep parking garages where there will be some kind of response by public safety, or even some kind of subway systems that we need to get that additional power in order to punch through that concrete in order to get that connectivity. So it's going to be really neat when we start getting these devices into the field to get that additional connectivity, again, on the uplink side, so we can provide information, team location, real-time video, telematics, whatever we can get, whatever the team needs through there. And now again, as we look at specialty platforms like maritime operations, how do we get them the additional range from something like an HPUE? So as they're operating offshore, we can get them that connectivity back to the mainland for the information that could become mission critical to them at that time. And this one I really like too. Many of you might be aware of FirstNet 1, the aerostat that was launched this year. But if you also start thinking of something like an aerostat capability, we were to put an HPUE on it to, again, get that range and connectivity over the horizon to get a hold of the macro network so that we can get that connectivity to the teams on the ground. So it's going to be really great and really exciting with this team when this device gets into the wild. Teams get it in their hands to kind of see how they're using it in ways that in my little slide here I just haven't quite captured. And with that, I will hand it back to Don.
Thanks a bunch, Travis. Great stuff. You actually mentioned something that I hadn't thought about in a long time. The FCC rules, because once upon a time this was LMR spectrum and everything, the FCC rules, when they created the PSST, the FCC rules said, hey, this spectrum could be used for at 3 watts of power and everything. Is that rule still in place? And I know we're not talking about that today, but in terms of just theoretically going forward.
Yeah, it's so you're on the edge of where I live, and maybe
okay.
Bob or Larry can answer this better. So, but yeah, the rule is still in place for the 3 watts from FCC, but the 3GPP standard is really what defines this down to the 1.25 watts.
Right. Well, no, if there's not a standard, that doesn't matter much, but it's interesting to know that there is room for growth in the future if someone is able to tackle all the technical problems that probably come with that higher power. Exactly. Interesting. Very cool. Well, Travis, thanks a bunch. Great stuff. Bob, tell us, you guys at Assured Wireless have been on the front edge of this. Tell us a little more about what's happening in the HPUE
Okay,
world.
good. Well, first of all, thank you, Travis. A very good overview of HPUE. Excellent job. And Donnie, I wanted to have a shout out to you, especially because right from the very beginning, 5 years ago, when this started talking about this, you've been a big supporter of HPUE. So just want to let you know about that. Thank you very much. And so I'm going to be talking about Assured Wireless's role in HPUE and in the technology and the products. So first of all, I can say that HPUE has really arrived. It took us over 4 years to get here, but we finally got approved products to offer to the marketplace. We were incorporated in August of 2016. We worked informally about a year before that in a incubator, technology incubator. Over the years, we've been able to recruit a seasoned team of wireless experts. As you can see in the right-hand corner here, a great team which has a lot of knowledge in everything from LTE chipsets to how to support them and the IP that goes with them. Now, Donnie, when we started talking originally, we were focused on band 14 only because that was a big hole in most product lines. And so we built up some prototype units for HPUE on band 14 and tested them on the early builder networks, such as Harris County and LA-RICS. And now, as that was happening, sort of the FirstNet RFP came out, and that was, of course, ultimately won by AT&T. And AT&T did a great service to the first responder community by immediately opening up all of their spectrum to first responders. So we said, uh-oh, we've got to now think about devices that can cover all the bands. But thankfully, we got to be a strategic partner of AT&T in January 2019, and that helped us along. And along the road, we have a whole portfolio of fundamental patents on HPUE and inner working. And the products we're going to show you here in just a minute have undergone very rigorous certifications. The PTCRB, which is International Testing Agency, of course, the FCC, and the AT&T and FirstNet lab and field testing themselves. So these products have been thoroughly vetted in terms of interference to other users, as well as interference to things like GPS. So this is a well-proven technology, and these are well-proven products. Now, all the products we have a general set of specifications. They're available both as modules and devices. And it's really important to note that these are complete radio modems. They're not simply amplifiers that have been added on to an existing product. These specifications I talked about are extremely rigorous and difficult to achieve. And for example, the adjacent channel noise that we generate has to be less in real terms than a standard handset. Now, the products that we have cover all the AT&T LTE bands. On band 14, we have what we call power class 1, which is the plus 31 dBm or 1.25 watts that Travis was talking about. On all the other AT&T bands, we have power class 3, which is the standard power class, which is plus 23 dBm or 200 milliwatts. Now, it's really important to understand that at all times, these products are under full base station control in terms of their power output. We only put out as much as the base station tells us it needs to optimize the performance. So when we log on to the system, we immediately identify ourselves as an HPUE device, and then the base station knows what our power limits are. Now, we fully comply with the 3GPP system, which Travis mentioned before, and we're a release 12 3GPP. And I have the plus on there because we're that. Plus, we have all these HPUE protocols going back and forth to optimize the system. We have a Cat 12 modem in there, which is for 600 megabits downlink and 150 megabits uplink. And it's really important, as Travis mentioned before, that the uplink with HPUE is optimized for public safety to allow that video and high data rates necessary to convey lots of information. So from a consumer point of view, we're always worried about downlink. Public safety is worrying about getting that information back up to the comm center. And we have all the standard GNSS GPS type formats built in. The AW12-HP is the essential HPU module building block. So this is the device that goes into all of our products. And I'll just show you with my cursor here. This is the module. Inside of that module is a custom modified Qualcomm chipset, LTE chipset. And then the module splits out band 14 from the rest of the bands. And under this area here is an ultra linear power amplifier. That's extremely important in this application, that there be no noise and harmonics and whatever generated. And last but not least is a custom built filtering system that filters out a very sharp filter, so the HPUE interference to adjacent channels is minimized. And also, since we're on a band 14 is a subharmonic of GPS, we have to make sure that we don't self-interfere with the GPS on board. The modules operate between 5 and 12 volts DC, and they have a very wide temperature range from minus 30 to plus 70 degrees C. And this module is specifically designed for use in OEM products. In a minute, Larry is going to show you one of the first implementations, but you'll see more implementations coming along very soon. Now, the device that we have currently is a USB-based device, the AW12. And this is a very ruggedized type device. It has, as I said, USB connection. It can be used in fixed and mobile applications. Again, 5 through 12 volts DC. Again, the extended temperature range. And the ruggedized case on this is IP65, water and dust protected. So this can go in a vehicle trunk very comfortably without having to worry about any environmental conditions. Now, we're very pleased to say that this device has a direct connection with the Digi International TX54 family of FirstNet ready routers. So you plug this thing into their routers, and it acts just like if it was an internal router. You get all the characteristics of an internal router. And it can also be used with mobile data terminals. We've tested it with a wide variety of mobile data terminals, with PCs and with laptops. And we'll talk a little bit more about the applications here in a minute. Now, for those users that have Ethernet connected devices, like many of the routers have, we have the AW12-EI. It's a companion to the AW12. It provides that USB to Ethernet connectivity, and it can be directly connected to routers and other Ethernet devices. So in addition to just doing that, it also has on board an LED, multicolor LED. So you can see, especially on initialization, as it goes through the connection status. It has a very wide range power supply on board for a wide variety of vehicles from 9 volts to 36 volts. And something else that's pretty perhaps novel is it has a PoE capability so that you can operate both the AW12 and this device from a type 2 PoE device, for example, from a stationary router. And as you see in the right-hand corner here, it has a companion mounting bracket to be used with the AW12 for a very convenient under-seat or in-trunk installation along with the associated router. Now here's a couple of applications, very common ones. So on the left-hand side here, you see AW12 connected to a appropriate antenna. This is a Centurion type antenna from Airgain. So this is a standard off-the-shelf antenna. It's connected to a laptop computer, kind of like your old dongles used to be. It plugs into the USB socket on the PC. We do have drivers available for Windows 10 so that it can be automatically detected, and it would operate as any standard cellular connection on the laptop. In this case, we can operate either from 12 volts from the vehicle power, or if you'd like to use an AC operation in some sort of a fixed application, it can use a power converter and plug in AC wall adapter. Now on the right-hand side here, we have the AC AW12 with an existing router and DC power. It's got the AW12 along with the same mobile antenna. And then we have the AW12-EI. So the USB connection from the AW12 comes into it, as well as the power connection. Now the EI has I'm sorry if I said it's a USB connection. Now from the EI to the router, you have a Ethernet to USB to Ethernet connection. So it plugs directly into the router as any wide area network connection we've made. On the DC power side, you have a battery, of course, and then we have two additional leads. We have one to sense the ignition and one to sense the sleep mode in the router. And so this allows the router and our equipment to be in coincidence, so that the router, for example, if it's still sending out a large file, the EI and the AW12 will not turn off automatically when the ignition power is taken away, so they can all work together. So I'm having a little trouble getting to the last slide here. Here we go. So in summary, the AW12 HPUE products are finally here after all these years. They're in production and will be available for sale soon. And we are accepting pre-orders right now. They're going to be distributed through Get Wireless and CNM, who's the AT&T FirstNet channel, and the Digi International TX54 router bundles. There'll be bundles with their products and ours. They'll be available through the Digi distributors. So again, I look forward to any questions that you may have at the end, but without further ado, I'll turn it over to Larry Greenstein from Airgain. Thank you very much.
Actually, come back to me for just 1 second, Bob. I just wanted to just make sure people are clear. This is not going to be an interference problem
No.
for GPS or for any other powered devices.
Exactly.
And then also you mentioned something that I don't think I've ever heard before. Assured Wireless has some interworking patents. Are you all kind of going to be providing some interoperability possibly?
Well, we'll talk about that in the future. So
in the future, all right, that's fine.
Thank you very much.
Okay, well, but it is that kind of interworking, though. That's what you're talking about,
Yes.
right? Okay, interesting, very interesting. So with that, I want to turn it over to Larry Greenstein of Airgain. Larry, you guys have developed a really cool product. Can you tell us a little bit about it?
Yeah, thanks, Donnie. Appreciate that. Yeah, got my display. Okay, yeah, here we go. The AirGain Connect AC HPUE. It's, as Bob LaRose implied, it leverages the Assured Wireless module technology. I'm Larry Greenstein. I'm the Senior Product Manager and Product Owner of this AirGain Connect product, and I'm gonna share a little bit about it with you. But first, I'd like to share a little bit about AirGain with you. So AirGain's been in the antenna business for public safety and fleet automotive for over 25 years. And the products in this product category include machine-to-machine, industrial IoT, GPS, LTE, 5G, and Wi-Fi antennas. And in the OmniMax product line, it's a product line of high-gain indoor antennas that directly connect to the device and again provide similar sorts of solutions like LTE and 5G and low-power WAN and GPS. And then over here you have the OmniMax high-performance external antennas. And these are more rugged outdoor pole mount, typically antennas for LTE, cellular, UHF, and a variety of other applications. And then lastly here, we have the Max Beam carrier class antenna product line. And this typically is used with small cells and wireless LAN solutions. So the product line is pretty complete. And the one on the top left, the mobile to mobile fleet public safety, this is the category where we've added AC HPUE, the product that we're going to talk about today. So this is what we call an antenna modem. It's a new category of device because it integrates the HPUE modem and the antenna into one housing. And so this eliminates the coax cable run that you typically have from the router's modem in the vehicle trunk up to the roof of the vehicle. And so this is an HPUE device that supports FirstNet service, but it also supports other AT&T bands, all of the other AT&T bands. It optionally comes with built-in Wi-Fi and GPS antennas, so you can hook it up to the router's location port, the GPS port, as well as its Wi-Fi ports. Therefore, thereby only needing one antenna on the roof to accommodate all of the router's needs. So it's pretty straightforward as to how you install it. It simply just bolts to the roof like any other roof mount vehicle antenna. Drill the hole, route the cable down to the router in the trunk or in the back of the SUV. But in this case, you're not routing a coax cable, you're routing a data cable. And the difference is you're not going to lose anything over the data cable in terms of performance. And we're going to talk a little bit more about why that's so important. If your vehicle already has an antenna on the roof, a conventional one with coax cables running down to the router, this can be left in place and you can add FirstNet service or HPUE FirstNet service by just adding the AC HPUE to the roof alongside the existing one, a couple of feet away. Then again, route your data cable down to the trunk and plug it into the Ethernet port on the router. All of these routers come with a WAN port right from the factory. And the only thing you might want to configure is once you've hooked up the FirstNet antenna, you want to make the AC HPUE your primary and then make the other antenna your backup. And that way you'll be on FirstNet almost all the time. In a very rare event when you didn't have connectivity to FirstNet, you could always fall back to your other modem. Some vehicles don't have routers because they don't have the need for all of the other accessories in the car, like license plate readers and cameras. In this case, you can just run the Ethernet cable directly into the docking station that the laptop supports. So those are the three ways you can install it. Earlier, you heard Travis mention the uplink being the weakest link. I just wanted to reinforce that here. In the downlink, you have a tremendous amount of power. But in the uplink, you only have 0.2 watts typically with your standard class 3 power at 23 dBs. So this very weak link is always what goes out first. You very rarely lose the downlink. When you lose the uplink, you get disconnected. And when you get disconnected, it doesn't matter how strong that downlink is. Until you get reconnected, you don't have any service in either direction. So that's where HPUE comes in. It boosts the power in the uplink. So let's take a look at what's inside. You have the base, which is made out of aluminum, and it's a very rugged heatsink. It's very robust. And the modem is bolted right into the heatsink. On top of the modem, you have the antenna assembly that directly connects to it, not using any long cables. So you've eliminated the loss between the antenna assembly and the modem. And then on top of that, you have the plastic cover, which is the radome. Over on the right here, what you can see is this is a typical calculation of what the loss over a coax cable is. These antennas that are used on public safety vehicles typically use this LMR 195 coax cable. And 5 meters is typically the shortest cable length that we sell for our antennas. For fire trucks, it could be double that. And at the center frequency of band 14, 793 megahertz, when you put all of these into a calculator, what you come up with is you have 2 dBs of loss at 16.4 feet or 5 meters. So it's much worse when you have a longer cable, but let's just stick with 2 dB for our analysis here. So what you see here on the bottom left is a typical power class 3 0.2 watt modem inside of a router operating at 23 dB max. You have the 2 dB of loss over the conventional cables up to the conventional antenna. The remaining is 21 dB or a degraded power class 3 down to 0.126 watts. If you compare that to the HPUE running at 31 dB with no loss on the cable because it's a data connection back to the modem, then you get the full 1.26 watts of power at the antennas, which is, it's easy to do the math. 0.126 versus 1.26, it's 10 times power increase over the power class 3. And what that results in, as Travis was indicating in his slide, is that you get a much wider area of coverage with the AC HPUE than you do with a conventional UE. So as Bob mentioned, it's a category 12 LTE modem with 600 megabits per second in downlink and up to 150 megabits per second in the uplink. And it supports all of the AT&T bands. So first responders who put in a FirstNet SIM that are primary responders, they land on band 14 and they stay there. Extended primary users, they also land on band 14 and they'll only get knocked off of band 14 in the extreme emergency situation where only the first responders can be on the network. And then enterprise users, if they put a standard SIM in it, they can get the improvement in performance that the AC HPUE brings by eliminating the coax cables and increase the range of coverage on all of the other bands. So that's a little bit about the AirGain Connect AC HPUE. I'm Larry Greenstein. My contact information is up above. If you want to know more about the product, there's a great deal more information online at the AirGain website. So that's it for me, Donnie. Back to you.
All right. Thanks a bunch, Larry. Great stuff. So, you know, you mentioned that it's 10 times more power, you know, 10 times gain. But that's comparing it to other external antennas, right? If it's a situation where somebody's trying to use their device from inside a car, I would assume just the interference from the hood or from the roof and tinted windows and things like that and maybe even have it in your hand would greatly make that an even bigger divide, right?
Well, it's a good point. So if you're just comparing holding a cell phone in your hand inside of the vehicle, certainly a conventional router with a conventional modem and one of our regular fleet antennas on the roof is going to outperform that, right? Because now you have a higher performance antenna and it's up on the roof of the vehicle as opposed to inside the vehicle. But what we compare in these slides is not the handheld device. We compare the existing router with a fleet antenna to an AC HPUE, where the antenna is built in and the whole modem and antenna is on the roof, and there's no loss in the cables. So that's why you pick up not just 6 or 7 times the power that HPUE brings you, you pick up 10 times the power because you have no loss, no lack of efficiency. There is no way to get a more powerful transmit signal in a cellular radio than this solution because the modem is directly attached to the antennas.
Wow. So you have the external antenna, you have the HPUE, and no cable loss. Sounds like a great combination. Congratulations.
Thank you.
All right. And so now we're going to turn to some questions and answers. I want to encourage everyone in the audience to please send us your questions. And I'll get us started a little bit by talking about a couple of the scenarios. Certainly out in the open, out in the desert, the benefits of HPUE are pretty straightforward. You've got this, essentially a doubling of the range, which, even by my journalism math with pi r squared, you're talking 3 times as much, more than 3 times the area covered in an isolated cell site. But certainly in most cases, you're going to have at least some of those sectors be associated with close to another cell site. But I really wanted to talk to you all a little bit more about other scenarios. In terms of an urban area, and Travis brought this up some, but Bob, what kind of gains can people see in an urban area? And frankly, am I not only going to gain some connectivity range, but am I also going to get better performance?
Yes. Okay. Thank you, Donnie. There's only so much I can say today about the answers. There's going to be a big launch coming up here shortly, but I can say that we've been very pleasantly surprised in the urban environment about the benefits of HPUE in terms of connectivity. That if you were to take our standard was a 5 megabit per second video feed and see how that performed with standard power versus HPUE. And we found that there was a very significant increase in connectivity with HPUE. So if you can imagine this scenario, you have a situation where someone's chasing a car, for example, or something like that. And even in a highly built up urban environment where there's lots of cell sites, there'd be a number of dropouts. And what we found with HPUE that the number of dropouts is much less, and you have just absolute connectivity during the whole chase. So that's one example. We've done tests in parking garages and found that again, as I think everybody mentioned today, the talk out range of these high powered base stations is much greater than the talk back range. And so going into these garages, you can often pick up the base station, but you just can't talk back. We've done a lot of tests in garages where you can have pretty good data rates and first and sometimes a second level in that garage without any outside benefit. So there's a lot of urban benefits as well as as you said, the obvious rural benefits.
Well, that's got to be huge for a situation like an ambulance responding to a heart attack in a parking garage. Suddenly, I can access all of my broadband tools as opposed to, hey, all I can do, I might be able to get some text out or a voice call, and that's pretty much it.
Yep.
Okay, very cool. And another scenario I was wondering was, public safety is always looking for reliability, and frankly, they need reliability at times when stuff's not working because there's been a hurricane, a fire, you name it. If I lose some of those cell sites or cell towers nearby, with HPUE, am I going to be able to reach maybe a cell tower that's still operating
Yeah.
further away?
Great question. We were very lucky to have exactly that scenario when we were testing in LA RICS. Goes back a couple of years, but they, for various reasons, one of the cell sites that covers downtown Long Beach was not turned on, and they had a big coverage hole there, and they shared the map with us as far as what the throughput was. It was a very bad situation. With HPUE, we drove in the same area and replicated their drive-through, and we were able to communicate with adjacent sites and be able to maintain pretty good megabit type communications in that area. So that's another benefit of it, is the ability to fill in the holes when there's an earthquake or some other scenario. It could be a man-made scenario.
Very true. Great stuff, Bob. So Travis, you mentioned some of the telehealth aspects to it, and I was curious. You talked a lot about if an EMT were to come to a home to be able to access all of their tools from a broadband standpoint. I'm curious, do you foresee a day where maybe we have HPUE devices that stay in the home to help monitor a patient that in the situation where maybe they don't have connectivity in a home? Is that a possibility, or is that just me?
That's actually a pretty cool use case. I could see how that might actually play a role as it gets connected to some of these devices, like you're saying, like a 12 lead or imaging device that might be pertinent to that patient to get that real-time connectivity. As I mentioned, I mean, that's a great example. Once these get in the hands of public safety and first responders, they're going to get some ideas for some real creative things to do that are going to make, like you're saying, some real lifetime benefits and changes for people in the field. So that's a great idea.
Okay. Well, and Larry, I know that AirGain Connect, we've been talking about it working from an HPUE standpoint, and that's an incredibly powerful application. But that platform, that whole notion of not having that cable loss, I would assume that's got to have a pretty favorable impact, even in non-HPUE situations, right?
Yeah, it's true. We've been doing quite a bit of drive testing in band 2 and band 12 out into some very distant areas that go first into the mountains and then into the forests, where you're not going to get connectivity from any mobile operator at some point. And what we've seen in some cases where even we get disconnected for 10 miles or so, we'll see the alternative solution, the modem that's inside the router, get disconnected for over 30 miles. So what we find is, if there was a state trooper that was heading out into those deeper areas of the mountains and the forests, he would have 3 times as much more miles of coverage with the HPUE solution, even though it's not operating on band 14 and not operating at high power, just on a conventional band, because of the improved efficiency of having the modem attached directly to the antennas.
Wow, that's impressive. That's impressive. And you also mentioned the notion of, you showed the example of a semi-truck. And, admittedly, a semi-truck does not have any priority or preemption and things like that. But frankly, in the areas of the country where a semi-truck would be out of coverage under a typical scenario, I mean, it's very rare that you would ever have so much public safety activity in that area where priority and preemption would even be an issue, right?
Oh yeah, that makes sense. Again, the long haul trucking If they're on routes where they have lack of connectivity and they want to see if they can improve that connectivity, then they should certainly evaluate this solution and see if it solves their problems. We know it'll improve their coverage, but every situation is unique. So we'll have to test their routes and see how well it improves their performance.
Very good. Well, now we're going to turn to the questions from the audience.